All right, this is the last section in 6.1, solving more intense equations where we're going to have to distribute, clear the parentheses. We're also going to have to collect like terms on the same side of the equal sign, and then we're also going to have to move variables over. So the first things first is I want to distribute and get rid of that set of parentheses. So when I do that, I get 6t plus 11, haven't done anything with that. Then I get 2t plus 12. Now here's where students make their errors. You may not undo something unless you're moving it from one side of the equal sign to another. So if you highlight this right here, these terms are on the same side. And if they're on the same side, they are meant to be simplified. So you're going to have to actually take 12 minus 5 and replace that with 7. And then I have the 6t plus 11. At this point, we need to move the t over to one side or the other, and then whatever side we establish for the variable, we have to move the numbers. I always recommend that you move the variable that has the smallest coefficient. It doesn't matter, but that's just what I recommend. So I'm going to move the 2t. And 2t is positive right now. So in order to make that go to 0, I have to do the opposite. And as long as I do it to the left and I do it to the right, I've still kept my equation balanced. So 6t minus 2t is 4t. Bring down the plus 11, and that's equal to positive 7. So now I've got my variables. Home establishment is on the left-hand side, and I'm going to subtract the negative 11. And so that goes to 0, and we get 4t is equal to negative 4. And last but not least, I'm going to divide by the number in front of the variable, and so t is negative 1. Okay, same idea. I'm going to distribute, and then I'm going to collect like terms. So I get 12n plus 4 is equal to 20n minus 30 plus 9n. So again, remember, I am only collecting these like terms first. So 20n's plus 9n makes 29n. And then I just bring down everything else that I haven't done anything with. So now I am actually going to move the 12n, and it's positive right now. So to make it go to 0, I have to subtract it. That is 0. 4 is equal to 17n minus 30. So now I have a home spot for my variable. I'm going to do the opposite of subtracting 30 by adding 30. And so now I get 34 is equal to 17n. Divide by 17, and n comes out to be 2. All right, on this one, start the procedure the same. 4t minus 12 plus 8 is equal to 8t minus 24. I need to collect my like terms. So in this instance, on the left-hand side of the equal sign, I've got two numbers that I can put together. Negative 12 and positive 8 is negative 4. And then I'm going to move my 4t That goes to 0. Make sure you don't lose the negative sign. And then I'm going to add positive 24. So that is 20 is equal to 4t. And then I'm going to divide by 4. So t is equal to 5. Now, the last two problems are what I call our special cases. They are either going to have no solution or they're going to have infinite solution. So when we're doing these problems, I want you to make a note. If the variable completely cancels out, then one of these two solutions will occur, okay? But you're not going to know that till you actually go through and distribute, collect your like terms, and clean this thing up, okay? So let's take care of that first. And I'm going to circle this negative because that's got to go with it. So I get 3x minus 15 plus x plus 12 is equal to 6x minus 2x minus 4. Anything that's on the same side of the equal sign has to be combined. So 3x's plus 1x is equal to 4x. Then I have negative 15 and positive 12. And so negative 15 and positive 12 is negative 3. Then I go to the right-hand side, and on the right-hand side, I have 6x's minus 2x's. So that is 4x's minus 4. Anytime you have a variable, the same variable on the left and the same variable on the right, I want you to do this. 4x is going to cancel 4x. And so now I'm left with this absurd statement. Negative 3 is equal to negative 4. Well, that is never true, folks. Negative 3 will never equal negative 4. There's no x I can choose that will make negative 3 equal negative 4. So in this instance, we will have no solution, okay? And we call that a contradiction. Now, the next one, I'm going to clean up. And there's nothing I can do to the right-hand side. So now I'm going to collect my like terms. 2x's minus 3x's makes negative 1x. And positive 8 and positive 15 makes positive 23. And at this point, what you see is that I have identical on the left to identical on the right. So this one, I mean, I could go ahead and solve it, cross off these x's, and 23 does equal 23. This is an identity, and it has all real numbers as solution. So we're either going to have no solution when you get something that is not true, or we have all real numbers when the solution is always true. And that finishes up 6-1 notes in Math 103.